Hi guys. Okay. For those who are tuning in virtually, we're gonna be starting in maybe like 5-10 minutes. Yeah. So if you have any friends that are waiting to come in, or you know they are interested, you just drop them a reminder. Then just get them to tune in online. Quite a free and easy one. Then yeah. Hey, hi guys. Thanks for with tuning in with us tonight. This is first in a series of talks that are focused on tech in architecture. We call it Tech Talks. And today's one will focus on immersive virtual environment in the architecture technology field. So with us here today, we have Gerard from IDA Technology. He's the CTO. And IDA Technology, they offer a whole suite of services for virtualizing architecture industry in terms of building, in terms of designing. And so I'll let him share more about what he does. Hopefully you'll find something interesting and we'll be taking some questions afterwards and just a short discussion. So thanks for tuning again. Over to you, Gerard.
Okay, so hi everyone. So my name is Gerard. Okay, maybe just quick introduction. So I work at ID Architects as well, IDA Technology. So the few things I do is firstly I work as an architect, so on projects, and through that process we are also looking at how we can optimize the way we do things, how we can move towards a more data-driven, evidence-based design. So we look to develop and improve tools, workflows, and processes in the delivering our projects. And that's what we do as a technology company. We actually package these tools and solutions and provide them to other architects, engineers, and contractors in the industry. So I also do a bit in education, where I teach at some of the IHLs as well as BCA Academy. So okay, a bit about the company I work at. So ID Architects has been around for 35 years now. So our journey, I guess you could say, is pretty typical for architecture firm in the industry. We've looked at tech adoption since long ago, and we specifically started in 2010 when BCA started to mandate a BIM submission. From then, we actually use outsource the services, but we look to build our own capabilities, start our own training, and eventually now we do everything in-house. So as an architectural practice, what we do is we actually specialize in industrial projects, so across multiple industries. So you can see some listed here, logistics, chemical warehouses, semiconductor, engineering, wafer fab, data centers. So we've actually gone into many industries, try to understand their requirements, their needs, and then design buildings for them. So we also do have some projects in the region. Okay, right, yeah. So yeah, anyway, that is the kind of projects that we look at. So yeah, these okay, so yeah, these are some of the projects we do. So some government clients, public clients such as JTC, as well as private projects. So master planning level as well. And okay, just to give you guys an idea of what kind of projects that we do. Okay, so now that I've fulfilled my obligation to the company, my boss is happy. So, okay, I think today what we want to talk about is really two main things, immersive environments and AI. And you know what this means to us as both an industry and specifically as designers, as architects, um, in these two fields. So, okay, let's just jump into it. So, okay, I think when we talk about immersive environments nowadays, it's hard to get away from the metaverse, especially, with big companies changing their names and having a lot of investment interest into this area. So the difficulty is what exactly is this metaverse which we are talking about. So I think there's no clear definition. People talk about it as VR can be the metaverse, VR, AR, MR is the metaverse. Web3 is also a basis of metaverse. So then it gets convoluted, things like your blockchain technologies and all that as well. So I think we will just use something that is fairly basic, defined here by actually McKinsey, so the research company. So here they determine a basic function of the metaverse that is some sort of immersion, interactivity, and agency. So basically, you feel like you're in a virtual space. You can interact with the space and you have agency in the space. So you can actually do something in there. And eventually we are looking at, okay, what more can we do with this as well? How can we interact it and actually really leverage on it? So I think, okay, that being said, let's start from a pragmatic point of view. Okay, what can we do with it? So for the construction industry, what we feel is the best use case is actually not necessarily best, maybe the most immediate use case would be in construction coordination. So one issue in the industry is, okay, we have been for a long time, but this is something that is difficult to interface with. Not everyone in the industry will have the ability to, go into the BIM model and actually see what's in there. So using VR, using immersive technology as an interface for BIM, I think is a very natural step. So this, democratizes data, especially for people who are not the professionals in the field, which would mostly be our clients. And so even just a, basic requirement of being able to see this BIM projects in an immersive environment where everything is one-to-one, it's to scale, it's easy to understand, it's a huge advantage for the industry. But of course, we wanted to do more than that to really look at application and how it helps. So what else we do with the software is BIM Matrix. So we actually develop it. We really want this to solve issues. So besides being able to go into the immersive space, we want to have agency there. So, okay, to be able to take measurements, do markups, communicate with each other. And after that, I think the most importantly is actually solve these issues. So if we had all this technology, fancy VR headsets showing our clients around and all that, but end of the day, it doesn't reflect in the physical building, our construction drawings don't get updated, then that's a bit beside the point. So we've also, developed tools so we can manage those issues, because when we do our markups or annotations, everything's captured digitally. We know exactly where this was drawn, who is doing this, who took the picture, where in the project is it, which area it's affecting, and who should we assign it to. So whether it's Archi, M&E, or CNS problem. So this would be the basic workflow in VR, where, okay, we start in the authoring space, typically a Revit model. We automate the export into a virtual environment. So one button press and 5-10 minutes later, you put on a headset and you're in VR looking at it. And through that session, we are actually collecting data about, the issues that you're discussing inside, any design changes, any compliance issues. And once we've got that, we also want to move seamlessly back into the authoring space, so all these changes can be updated. So simply put, this is what it looks like. In application, it's a bit more like this. So we are never looking at models in isolation. We are always looking at multidisciplinary models, right? So your Archi, CNS, M&E, subcontractor models, and all that kind of stuff. So when we look at it, typically what we get is a federated model, and it looks exactly like it would be in the final product. So then we also look at, okay, what other critical features are there that we require to really have this communication and collaboration? I think first and foremost is definitely a multi-user environment where you can actually see and interact with other people. Because, okay, VR is great, you can see the BIM model and all, but now you put on the headset and you can't see anyone else, and no one else can see what you're seeing. So for us to set up the right environment where we can have multiple users, not just in the same physical space, but across different physical spaces was very important. So that's one of the features we developed. I think one of the very pertinent use cases also would be, deployment on site and HQ, so that that kind of collaboration can easily happen without people having to travel down to site, or the site people having to come out into the HQ office. Things like outstation specialist consultants, which can typically come from overseas. It's also a lot easier to communicate with them. So if we can bring them in the virtual environment rather than flying in, going down to the physical project just for, okay, I need your input for these few items, we can easily do it online. And of course, I think the one that is the most easily appreciable is to show our client the design. So, typically if we show our plan, section, elevation, all these are very abstract things that the clients don't understand. So even if you show it to them and yes, we understand this change, it's always the case, go down site and it's not exactly what they expected. So yeah. So we try and get closer, we show them renderings and stuff like that, but it's also not really one-to-one communication. So we by putting them in the virtual space, going through with them, it's like doing a site walk before anything is actually built. So we found that to be incredibly useful. And we want, okay, when we do coordination, we also want everyone to be on the same page. So, just hosting on a cloud file, making sure no one's looking at an out of date coordination file and all that is also something that we do. So, okay, I think this, it's an example of pragmatic use case which we've developed and applied now. But then more than that also, bigger question would be, okay, what is the role of the architect in the metaverse? How do we actually come into this? So if we talk about, the metaverse as a metaphysical universe kind of thing, I think the first thing that everyone thinks of is, okay, this is a gaming space, but especially in, today's environment where everything's happening online, everyone's used to teleconferencing now. Do we want to leave, designing of these virtual spaces, which actually we will experience a lot, to game designers, or do we want some role to play in this? So I think that is definitely something to consider. Things like virtual real estate. How can it, actually play a role in this metaverse, and whether, the architect, the designer, as an expert in designing spaces that people will use, do you have some expertise to contribute to this metaverse? So let me see what is that place. I don't know, I can't get the videos to play, but it's always like that, right? So, okay, anyway, this is, I think, an example of what's going on in academia. So, I don't want to talk too much about the content of the projects because I'm not that familiar with it and I don't want to, butcher their intent. But basically, these are projects from the Core 2 Studio in SUTD, in which they are actually examining, not just physical space, but what does it mean to design a metaphysical space? What is that experience, and what can it do when you are not limited by necessarily by physical limitations, your structural constraints and even code compliance. So what then, actually can this pure kind of space do, and how would people experience it? So they actually came up with a concept, like a typical design studio. But what was different is they designed it to be experienced in VR, so as an immersive experience. So if the videos were playing, you actually see snippets of what was going on inside. But yeah, okay, we'll leave that for another time. So, okay, then I think that is just something to think about for, immersive environments, metaverse, VR, AR, and all that. So interestingly now also, now the very newest buzzword is AI. Everybody has heard of ChatGPT, how it's going to change everything, how it's going to be very disruptive, how it's going to make everyone jobless and all that kind of stuff. But if I think if we step back and take a look at it. Okay, what is AI, right? So also this also can be quite a hairy definition with no real clear boundaries. But okay, we'll go with this one as well. So it's just ability for some computer or some digital apparatus to do tasks commonly associated with intelligent beings. So this is okay, very high level, very broad, but then we can go for a very technical definition as well, which is stuff like this, right? So okay, what actually is machine learning? So you have all these things, your SVM, your regression, your KNN, and all your different models that are essentially statistics on steroids. So we are trying to, find patterns and make these digital models kind of simulate thinking for themselves. So, okay, then if we have these high level, agnostic kind of definitions, then what does it mean for us as an industry? So we've seen, all these definitions out there: computational design, optimization, evolutionary solver. So where exactly is the line between, AI or what is just rule-based kind of thing? So I think the terms get convoluted quite a lot. So I won't really try and attempt to define it. I think no real point doing an exercise in semantics here. But I think what's more useful is to just look at the use case. Then you can decide for yourselves whether what is AI, what's not. So okay, what we have here is a typical project flow. So from start, when we get the brief, all the way until we finish construction. So what I'm showing here is just, okay, typically what kind of AI associated technologies we could apply in the different stages. So earlier on in the project, in conceptual studies, when we are doing design development, we can use tools that typically can be termed under, generative design, where these are tools that come up with different design options for us. So especially useful when we are looking to explore design options. So instead of the typical approach where we try and start with a simple idea and refine it until it's in its ultimate form, we can actually define the process, define what parameters we want, and have it generate something. So then later on, we will also have things like efficiency, automation tools that can help us do tasks that maybe might be calculated, it's more demanding on calculation and stuff like that, or very repetitive that we do over and over for every project. So even things like for production, for submission, we can design tools to help us there as well. And yeah, all the way into manufacturing, fabrication. So how do we actually take our designs and move them into fabrication on the fabrication floor? So those are all things that can be done. So I'll just go through briefly some of the applications that we use. So these are some things that Dynamo can do. So Dynamo, in case you don't know, it's the computational plugin for Revit. So it comes with all your newer installs of Revit by default. So these are the things that typically can do, but let's look at actual examples. So okay, in more real world terms, say we needed to add a prefix to a sheet name, which we need to do it for every authority submission, right? So whether it's your URA, BC submission, we need to do it over and over again. And the trouble with this is that there are incredible number of sheets in every project. So you're talking at least 100, 200 sheets. And just going through that is inane, like clicking, changing the prefix and all that. So definitely there's a much better use of our time than doing this. Barely qualifies as documentation. So what we do is simply run a script, grab all the sheets that we want for submission, put the prefix of the authority that we're submitting to, and call it a day. So very simple, very mundane, saves an incredible amount of time. The other thing to do with sheets is renumbering as well. So it's almost impossible to determine the final sheets for your project at the start. So we do something first, and eventually we insert sheets where more details, more information is required. And yeah, it can get quite messy, you know. You have different suffix, you have A, B, -1, -2, and all that kind of stuff. So to keep things in order and to make sure, you know, eventually it doesn't get messed up, we can also use simple logic to pull all the sheets in order and number them accordingly. So also a big time saver here. Different things like access and standardization are also, you know, challenges that we face daily. So what you see here is actually our office standard. So our office standard is stored in Excel, right? Where we have, okay, certain elements to be represented like this and so on. But this, of course, does not link to our actual projects because it's an Excel file. So what we do is we can have an interpretation layer in between there, which is Dynamo, to say, okay, go and look at this file, figure out, you know, what colors it's using, what kind of fill, what kind of hatch, and push those standards into every one of our projects. So this is great for standardization, especially, you know, if we update our office standards, we don't need to worry about going to update every project again. So as long as we open a new project, it will have the latest standards. So that helps a lot in management. So things like B score also. So okay, B score has to be represented. You know, you want to split up your different LSI by color and all that. So traditionally, it would be a hassle. So unless you've drawn everything, you know, on the right layer in AutoCAD and all that kind of stuff, which is quite unlikely, it's just going to be a huge endeavor to go and color everything. But you know, it's an authority requirement, so we can't actually go around it. But you know, running the script is just, yeah, one step, one button press, and within seconds it's done. So okay, then let's move on to, okay, all the videos don't want to play. Yeah, okay, the more interesting applications of it, which would be, you know, more on the design side. So instead of, yeah, like I said, you know, looking at one option, we can actually explore many iterations of our designs, especially when, you know, there are calculation elements, things like, okay, every project, you know, has a GFA that you must hit, a certain program breakdown. I think these are parameters that we cannot get away from. So, and it's difficult to, you know, figure out all these things in multi-story, multi-block buildings. So, but it's pretty simple for the computer to figure out. And, you know, when you throw all your requirements together, even for a simple building, you know, just GFA breakdown, okay, access, your RAM going to every level, having enough headroom. So these are very high level, you know, fit into the site of all your setback and all that kind of thing. So very high level initial design things. Even just to do that, it's you know, not easy to juggle everything and make sure all the pieces fit. So especially so when we add more and more, you know, requirements, compliance issues, then it's easy to, you know, lose sight of one and suddenly come back, hey, you know, we've done a lot of rework because all this wasn't considered. And another big plus for this is, okay, so most of the technologies which I talk about have a lot of synergy with each other. So for example, if we use, you know, computational design in this case to solve these problems, we can also use it in tandem with VR. So as we are modifying the form, we are getting very detailed quantitative data from it. So we know, okay, exact floor area, we know the breakdowns, and all that, maybe cost even. But we don't necessarily, or the client doesn't know how, okay, you show me all these figures, they work, but how does it feel like? You know, I want to go in and see the space, is it big enough? Can I do this activity and all? So by using it with VR, we actually can reap the benefits on both ends. We know that, okay, the numbers work, and we can go in and see, okay, you know, how does it look from this view? Can we actually see this thing, that thing from the side? How does it look like from the street corner? Does URA like it in this context and all that kind of stuff? So there's that. And yeah, a lot of different applications. So here we are showing one on fabrication. So basically, we actually embed all our design intent into a generative script. So we design this facade and we say, okay, we want it to have comply to certain things. So for example, don't go too far away from the structural beam behind because it'll be very hard to support. We want it to shade the area behind, but not too much, so still allow some light in. We want it to allow ventilation. We don't want it to block certain units, and of course, we have some requirement on the aesthetics of it as well. So basically, we codified all these things, embedded into a script, and every time we change our requirements, the form will update as well. And the big advantage is we can actually take all this and quickly document it also. And all this will be procedural. So if we change an upstream step, like, okay, client changed their mind because why not? And suddenly they don't like it, they want to tweak the design. Typically, we will try and tell them not to do it. But in this case, because we've already got the whole workflow process down, it doesn't actually cost us extra. So we are actually very fine to do that. So, okay, I think all that is not that interesting without a demonstration. So let me just try and show you some example. Okay, so here we are looking at Rhino and Grasshopper. So Rhino is just 3D modeling, right? And Grasshopper is the visual programming component to it, where we can actually put some logic into geometry. So a lot of what we do is putting logic in geometry and then extracting another set of information out of that. So okay, let's look at a problem that is very typical. It's in every project. So car parking requirements. So we all know the requirements. We know the sizing for the lots and all that kind of stuff. But end of the day, when it comes to the project, we still need to put them in. So we can have a boundary, and we just need to know how many car parks can we put inside here. Does it fulfill the LTA requirement? So instead of finding the most junior guy, go and pack everything inside, which is going to be a hassle for someone, we can write a script to handle that. So we know the requirements, okay, size of the lot, size of the driveway, one way, two way, and all that kind of stuff. So by letting the computer know the rules, we plug it in, and then you can see here that it just populates the lots and tells us how many. So then the challenge with this also is that there are actually many different ways to fit in this car park. It's not, this be all and all thing. So we've also built in controls where, we can flip those on the parameter. So parallel parking lots on the parameter, perpendicular lots, and what kind of difference that gives us. So this also allows us to quickly test many different plots. So if we said, okay, instead of that plot, can we try this one? And we get a result. So even if it were, slightly more complex plots like this, so not really rectilinear, we can actually create that as well. So you see the layout here, which actually matches pretty closely to the one below it. So things like, okay, whether it's indoor, outdoor, space for structural separation are all parameters that we can tweak. So I think the other thing is, okay, why do we need to do this as, architects, as designers? Because this seems like a very, programming computational job. So what we've done is, because we've, designed this script, we know exactly how we're going to use it as well. So one of the features which we built in is, you notice that there are some lots here which are actually highlighted in red. So these are lots that actually encroach onto the driveway just by a bit. But we can set how much that bit is and define that. So in these cases, we want the script to, okay, don't count them, but just let us know they're there in case, we're really short of one lot, then yeah, that might be a potential waiver case. We look at, we'll find the one that encroaches the least, and okay, LT, can you allow this lot based on whatever requirements? So that's one thing. Okay, so another thing which we use a lot for almost every project is RAM. So ramps, and all their different iterations and flavors. So your pedestrian ramp, your car ramp, your heavy vehicle ramp are essentially the same thing with different parameters. So different widths, different allowable gradients, different turning radius, and all that. So this is also a great candidate for parametric design. So typically these are not too difficult to calculate as well. But once you have, a ramp moving up in 3D in more than one axis, especially when you need to calculate gradient along the curve, then it can be quite tricky to do in 3D, 2D. So modeling it in 3D is a lot easier. And we always have a clear idea of, okay, after a structural offset, how much headroom do we have? So, okay, I'll just adjust the script a bit. So, we can adjust where the entrance position is, somewhere at the front, somewhere at the back. Size of the RAM, right, in 2 dimensions and not a few other things. So we've hard-coded the gradient to stop at the code limits. So, once 15 straight, once to 20 on the curve and all that kind of stuff. So, okay, then here's the thing. Can we, make this have a little bit of intelligence here? So we can tweak it to, fit our project, but then we can also get the computer to do it instead. So here you can see that now the computer is figuring it out, and we've given it some optimization parameters. So it's not just doing this randomly. We've told it, okay, for this RAM, can you figure out what is the least amount of CFA we can have? Because why build a bigger RAM than necessary? Because that's just money. But at the same time, we don't want to have, the smallest, steepest RAM that will be very hard to drive up. So you're saying, okay, but while you do that, try to limit, the gradient to not the maximum. So that it's, a bit more easy to drive up and a bit more usable. And while you're doing this, always make sure that we have, our required headroom there. So this for the computer is not too difficult. You can see it's learning pretty quickly. It's figuring out, okay, the big RAMs actually aren't that good. So we're trying to go for the smaller ones, which would score better. So we can put in, quite an amount of different things to be juggled and calculated at the same time, like say, okay, in the middle of the RAM, can we maintain a certain ratio of the sides so that we can fit many room there? So all these are things that we've implemented, and yeah, eventually it will quite quickly solve it. So, okay, let's go on to a more design use case. Okay, so this is urban design use case, right? So similar to the facade design, what we've done is we've tried to encode all our design intent into this script that then generates a scheme for us. So, okay, among the things we've put in are like, okay, what kind of total GFA do we want? What GFA breakdown do we want between commercial, residential, your office space and whatnot? We want, a green space, open the sky that can, become a community space. We want all the residential blocks to not overlook each other, to have a good view out of the landscape, and terrace down towards the waterfront. So many different design conditions and intents that we've embedded it within here. So definitely more than I've mentioned there as well. So typically, I think to even come up with a viable scheme that can fulfill some of these requirements would take a reasonable amount of time, maybe 2 weeks or so. So what we've done is, yeah, we've translated all of them into, your geometrical conditions and your layout. So what we can do now is we can actually run the script, and with all these concerns, it would, generate a viable layout for us. So that's one. And if we say, actually, okay, we didn't really like that, can we try something different, right? I mean, everyone's heard it from the client. So yeah, no big deal. We try something different, and we can then try and do more. We can evaluate them, based on their merits, whether it's okay purely aesthetic, we just like the way it looks, we don't like the way it looks, or based on certain metrics. So things like, okay, which one has the most blocks closest to the site entrance, or things like that. And then, yeah, start to see which designs are actually better. We can also do things like changing the input parameters. So if, say, okay, maybe we just didn't want this green open space to be here, we can quite quickly shift it over. And then, okay, let's say rerun the script. So now it's figuring out, okay, we don't want buildings there, we try and keep another area open, and yeah, come up with another result. So this really lets us go into a very iterative style of design. It's definitely quite a paradigm shift, rather than okay, the design has to be something like this and we want to solve all the problems here. This broadens our design landscape by a lot. So okay, then maybe let's look at more contemporary, actually classified as AI design, no, sorry, AI implementation nowadays. So, okay, I'm sure you've heard of, your AI platforms like Midjourney and your DALL-E and whatnot. So this is actually something like that. So, okay, I think the trick is, or not really, the important point for us is, okay, how can these things help us in architectural design? So Midjourney and all that, you can enter prompts and it gives you, image feedback, which we can use to a certain extent, maybe if you're doing a mood board or just want very exploratory ideas. But other than that, I think it's quite limited in its application and use case. So one thing we can do is, okay, can it come up with a more specific visualization also of what we want? So the key here for the AI is to have control over it. So rather than okay, just something that looks good, which is, yeah, for any artist that will be enough, right? Okay, we want something within these parameters and keep figuring out until, okay, this looks good. For us, we want it to more, look specific. So, okay, let's just look at an example. Okay, let's say, for example, this, right? So this is just your very typical, not even a BIM model, so probably a SketchUp model or something. So how do we actually, get this to look like something or to be a bit more presentable? So if we actually just, generate it. So you see AI without control, right, has shown us this, which is not terribly useful for us. It has no context. So, okay, let's try better. Let's tell the AI what we want. So, okay, this is architecture, right? So we want to tell it's a building. Maybe we want to say something like, okay, it has greenery. Let's say, okay, photovoltaic. So okay, just stuff like that. It's always better to be descriptive when talking to AI. So, okay, we could try that again. And okay, slightly better, but also not terribly usable because it's still out of bounds of what we want by quite a bit. So here we have other things we can use, which is something like AI on top of AI. So, when you can't control it, you get the AI to control the AI. So we say, actually, we are looking for something like this. And within these parameters, so I'm just going to change some parameters without explanation first. Okay, can we make something that looks like this, but, give it our prompt and polish it a bit? So that was negative because I didn't click enable. So yeah, just doing weird stuff, right? I mean, interesting, weird stuff, but okay, wait, now this is something. Oh. So let me just set everything right. Okay, so now you can see the AI actually knows what to do. It's actually, created it based on that, and it's given it more information. So, okay, let's say this is not exactly what I want. So, it's not like we need to feel bad if we ask it to do it again, so just do it again, right? And okay, let's say, for example, yeah, maybe this is more like it. This is more like what we are thinking of. Okay, let me just set it so it's this ratio. Okay, so we actually don't want a square image. Let's say we want more landscape image for presentation. Okay, let's say, okay, that might be a design that we are looking at. So how do we further refine it from there? So now you can see the AI is actually learning, and it's come up with something, on its own, but also within quite tight control parameters. So we can iterate there. So, okay, that's something we like, and then have another go at it, right? So basically, we will just go through this iteration process, add more details, figure more things out, and okay, now this is actually looking like quite a decent rendering. Really has, some details, and it actually took those prompts, those words that I fed it, and put it into the design. So now this is, some utility in the AI where it's actually, at least in a usable form, right? So yeah, we can keep going through this until it's really what we want. Of course, we can adjust the prompts and all that. So okay, maybe the last thing that I would show also is, okay, we have, all these tools and pretty cool and all, but really where we can leverage the most is when we use all of them in tandem. So let's say, okay, we had this, generative design process, and now I want to go generate many designs, and after that be able to render also. So, okay, let me just tweak a bit. Let's say, I just want to make it, look simpler, so that we can have more interesting results. Okay, so something like that. Now, we can actually take that as an input and feed it in here. So let me just clear this. Right, so that was our image. And okay, let's say, let's add a few more terms there. Let's say we want it to be futuristic. We want it to reference Zaha Hadid and whatnot. Okay, so a few more prompts in there to make it interesting. And then we can start generating. So you can see, potentially this could fulfill our design requirements, but of course it's taken it and really done something pretty interesting.
Yes, yes.
Okay, so yeah, I think now you are looking at actually really quite interesting concepts, render based on a very grounded design base that we did. So we can, run through iterations, get a render out in all in much quicker turnaround if we use these tools. So yeah, okay, I think probably that is about it. Um, so, oops, okay, the PC crash. Yeah, okay, well, just in time anyway. So, yeah, okay, I think, yeah, I'm not sure. The Zoom guys can still hear me, right? But, sorry, they can still see the screen. Okay. No, it's like completely started. Um, but can we hear them over these speakers? Can we hear them if they have questions? Okay. Yeah, okay, never mind. Let's just end there for now. So yeah, okay. Let me just get this computer restarted because technology knows the best time to break down. So
Okay, thank you so much, Gerard, for your very wonderful presentation, especially for the last part, which was actually super interesting because I mean live demo is always the best. And I think you just did like a full day's worth of work in just a few clicks versus, for example, a firm that doesn't have any of this technology enabled. I can imagine myself, and I have been there myself on SketchUp, you know, doing 20 different design options based on the same messing, just for the client to reject every single one of them, right? So then this saves a whole lot of work. Okay, but I guess, so for those who are joining us virtually, you can just type in any questions you have, and we'll get fed, and we'll pick and choose which ones you want to answer lah, right? So the more interesting ones.
guys here can just ask anyway.
Yeah, so those who are here, just shout it out. Um, I guess my first thing is you mentioned about democratizing data, democratizing the whole design process, the flow, getting clients involved into the nitty-gritty of what we do. So maybe can you share some experiences on how you have converted new clients and what are some of their responses about, like, before they realize maybe they think, oh, virtualization is just a fad. Why do you need this BIM technology thing? It's just government trying to do something. So can you share some responses, how you converted them, and some maybe what they benefited out of it?
Okay, yeah. I think exactly like you said, right? That is um the sentiment we get a lot. Like, yeah, okay, VR is cool, but it's gimmicky, and yeah, why do we need it in a project? So I think some of our more pertinent use cases, right, would be especially when the developer side and the end user are not necessarily the same person. So this usually is, from more experienced developer, like, hey, our PMs are also pretty savvy already. We don't need you to provide VR for them to understand the project, which is true. But then you come to the end user, which is really a layman, right? So if you are designing a hospital as a doctor, if you're designing an army camp, this will be your camp commander and all that. They have no idea about BIM, not even BIM, like even your 2D drawings, they have no way to understand. But they have very specific requirements for the building. So your doctor needs to be able to operate your surgery room, your camp needs to be able to do specific training, which usually they don't even get to communicate to the designer. So by having all this be able to be presented to the layman, I think it provides a lot of value. So in our projects also, we've shown, the end users and stakeholders of the project, like, okay, this is what it will be. This is what we design based on what we know, and they can say, okay, this is yes fit for use, or no, actually they need to tweak this, tweak that, and yeah, we've gotten very quick buy-in. So once they see it, we do maybe one update, and like, okay, yes, this works, and we can move on a lot more quickly with a lot less, back and forth and tweaking in the project. Yeah.
Yeah. So I guess the way of putting it is basically bringing agile workflow into architecture, which is traditionally, not a very agile industry, which is quite amazing. I mean, I've never worked with MOH or healthcare, but I guess those of us who have worked with healthcare, we know how many many requirements they have and how difficult it is to
Yeah,
satisfy
and
each
how
and
many
every one of them.
stakeholders there are.
Yes, and also the patient care, and not necessarily the architect not necessarily knows all of these requirements until it's communicated to them by the end user.
Right,
Yeah.
right, yeah.
So okay, I guess yeah. So we from what we've seen so far, it's quite clear to us as designers, as architects, what are the benefits. Back again to what you just showed us, maybe you can just share with us, as a practice who actively develop such technologies, what is the response from your peers? Um, have you gone to other companies who requested you to show them how to use these tools, or maybe they can even purchase some of these grasshopper scripts from you, from your peers, and also the demand for talent in the field.
Okay, so yeah, definitely we also look at equipping the rest of the industry with these tools. For us, our perspective is, yeah, they are just tools. A lot of people would be suspicious. Like, why would you help another architect? This is your competitive edge. But for us, it's, we've never competed as architectural practices on which office has the sharpest pencils, right? Or who has the fastest computer will win the job. Doesn't make sense. So for us to share technological tools, we are very happy to. And in the end, I think our competition is really on a design basis, and how well we do at that. So okay, response is difficult. I think especially for architects because it's a very different paradigm from what we learn in school. Especially the whole approach to it. So at a very fundamental level, we learn design thinking, which this is how we solve the problem. But it's almost at the other extreme, where okay, now you have to be very logical. You have to actually the computer doesn't understand anything that's outside your mathematical logic. So in teaching a lot of the courses, I found that this is a stumbling block for a lot of architects. I think the other challenge also would be to get the more senior stakeholders in the industry to see the value in this, just because it's so radically different. It's not like, oh, okay, with CAD we can work faster because we can correct mistakes quickly. In the end, it's still essentially the same thing. It's still drawing lines, not much difference in workflow, but with a computer. But now when you're challenging really the way we work, it's definitely difficult to accept. In even in school for them to understand what you're doing. So I can show you, a very well thought out project that is generative, but it fills all the design requirements. And yeah, we can have a good critique about it. That okay, this is good, that is good. But end of the day, you can have misconceptions like, okay, great project, but then didn't the computer design everything? So what do you do? But of course, there's a lot of work before that where you have to tell the computer exactly what you want it to do. So probably the biggest barrier would be a lot of education where people can actually understand what is going on and not see it as a black box, but actually see our role in it.
Right. So I guess just share a bit. How do you think current students among us or current practitioners, what is one of the key things that we can start to get ourselves on these kind of platforms?
Okay, I think the good thing now is that there's a wealth of information out there that it's easily accessible, online through Google. There are also courses. Um, so, okay, BCA Academy does one that I teach in computational design with Aloysius. So like you can see from the SUT example, I think the schools are actually moving towards the newer thinkings and methodologies as well. So yeah, it's probably up to us to be more forward thinking as an industry. Yeah.
Okay, so before we move on to questions from the audiences, we've collected a couple. I think joining us today online, we have architect William Lau. So he is on the SIA Council and he leads the digital technology arm. Um, I think I think he will like to invite him to just share a few words from his experience and what he actually sees on the ground at a higher level, at an institutional level, from SIA standpoint, and from also from BCA standpoint, talking to authorities, talking to ministries, what they think on this industry push for the next, basically part of the industry transformational roadmap. So I think maybe you can share.
Hi, not sure. Can you hear me?
Yeah, go ahead.
Hi. Okay, great. Thanks, Gerard and Evan, for this very interesting talk. You're right. I guess we are moving into a so-called, as you're all aware, we are moving into, they're going to launch, in fact, Connect X will be launched very soon, right? And I guess it's going to be very daunting, especially for the firms who are just starting to have this digitalization. And as you're aware, I think this is going to be a huge challenge for the whole industry. But what Gerard have shown is really is make it so simple, right? The GD and the AI and all that. But I'm quite sure it's not easy to get there. So perhaps, but nevertheless, I think he's shown a lot of so-called possibilities that firms can really look into, and it can really help us in our practice. However, having said that, we need quite a bit of the challenges to be able to do that. First of all, the mindset change, right? And secondly, to hit that competency level, as actually put in the question, right? Make it so simple, but look at the script map just to get the car parking solution. It can be quite daunting. Yeah. So the journey, right? In fact, the learning journey here, unlike other so-called easier tasks or learning how to do a simple software and all that, actually it's not an easy thing to learn. Even you pick up, right? I mean, there are a lot of things. First of all, you need to have the background knowledge, right, to be an architect, to face with all these challenges. Then you have to look for the solutions and what are the possible solutions out there. And there are so many, right? You've given some examples here, right? Dynamo, Rhino scripts and all that. So it can be mind-boggling to the newbies. At the same time, we come to a conclusion that we cannot sit down and let things go by. Otherwise, we will literally be left behind. So I'm quite sure we're trying to reach out to people in the industry or architects out there who have the experience and have the so-called willingness to help out and all that. We're really looking for some of these solutions to help out, especially the smaller firms. The bigger firms, I'm quite sure they can find their own level and find their solutions. But what we're concerned is the smaller practices. A lot out there, we're concerned that when the Connect X kicks in, a lot of them will be left behind. So we're trying to find people who have some alignment and how we can help the small firms.
Okay, I guess Williams overall he's trying to maybe in a question is how do people keep up, and especially the smaller firms. Yeah, because I think the smaller firms actually have the most to gain by being very productive.
Yep. Okay, definitely great point, but I think that's a difficult question, with no clear answer. Part of it is definitely, having someone with the familiarity on board. You need someone to really drive the change, whether it's your principal that's going to drive himself or you hire someone to drive it. But ownership of all this is going to be important in every firm. Because like you said, no one can actually do it for you. So the best way would be to internally have some sort of transformation plan to keep up with it. On the technical side, it would be, certain commitment to the tools. There's never a good time to start to pick them up. Everyone's always busy, and if you're not, this is not the first thing that you're going to look at to learn. So it requires a certain amount of resolve and commitment and painful decisions to actually develop the proficiency. So yeah, I don't think there's a simple way to put it. Like, there's no magic bullet or panacea thing that do this and you're suddenly technologically advanced. Yeah.
Okay, I guess there's another question asking on what do you think, how do you think it will affect the future focus on the job scope of architects going forward? Will they focus on creating AI tools instead of actual design? I think it kind of links to William's question, right? What's the focus going to be and how do people get onto it? For myself, I played Visual Basic back in 2003 or something, and then Visual Basic now is very different. I've done some Python. I love Grasshopper. I don't know whether your remote desktop is still on to zoom into a bit of the Grasshopper scripts, which I believe can kind of like help to clarify a little bit. So Gerard's actually using all of this on his Surface Pro. Then he just remote desktoping back. And I mean, after work hours, a couple of clicks, he's basically done the work of quite a few people if you're using traditional analog design. So that to me, I really see the value proposition. So if you zoom into Grasshopper itself, you can see that they are actually using natural language to do this, which is also a term that AI developers really, that's how you interface with AI. You use natural language. I think I'll let Gerard go through.
I think, okay, visual programming is definitely a good place to start because it allows us to, apply these computational processes, right? Without having that burden of having to learn the syntax of textual programming. So that in itself can be quite a big barrier to entry where, okay, you have to go and learn actual code first. So you have to go and pick up your Python or whatnot. But here it's like, okay, everything is a bit more interface for, your beginner user. You can actually dip your feet in, have a hello world without going all out and doing a computing course. So yeah, I think that is really why Grasshopper is probably one of the most used tools in architecture.
I think you just run us through maybe like 3 connections and just talk us through. You don't need to show on, I guess, on Rhino. Just show how it links and what it means actually.
Okay, probably it's easier if we start with a new example. So let's say, okay, what is procedural, what is parametric? So okay, if you wanted to just draw a box of a building, right? So here we can just choose a box node where now it's asking us, okay, what kind of box we want to draw. So what kind of size? So let's just put in some sizes there. Here, okay, you see we've gone through a few steps just to draw a cube here, but the important thing is this cube is now what we call parametric or flexible. So we can change input parameters and give it different properties. And now we are doing it, the simplest way by just changing a number. But we can, of course, use algorithms to drive this. Algorithms that have certain logic in design, in compliance and all that. Okay, how far away do these blocks have to be? So at its most fundamental is something like this, but of course we added, many layers of intricacy and complexity over it. And yeah, finally you end up with a script that does like kind of what I showed before.
All right, thanks for the instant demo. It's quite hard to come back down to this starting level when you are already working with what you work with. Okay. Anyway, so I guess for Hui Yao's question on focus on architect's job scope, maybe I'll invite William. Do you have some thoughts on this, coming from the institutional level? Yeah, William, you're still with us?
Okay. Great. You can hear me? Yeah. Okay. as you're aware, the architect's scope is actually very wide, right? From design all the way to project management. Of course, with the help of these tools, right, it will in fact help us greatly in our design process. But however, the fundamental is still that as an architect, your design is still your forte. While the script looks like it's doing all the work, but actually behind it, when you put in the so-called the rules and all the so-called assumption, is actually you're exercising your design skill, right? Where you put up the script. The script is just a tool whereby they can generate a lot of so-called forms and solutions for you. But in order to reach that, as an architect, you still have got to have the input, why you put in certain rules, what is it that you require. So in fact, the moment that you start to change that, your solution that is derived will be different. So while to one hand you say that, oh, will this replace the architect? I don't think so. However, as an architect, we have this now becomes a new journey for us that we can now look into. Right? Of course, not for everybody, but for those who are keen into this, this is one of the so-called, perhaps a new, I wouldn't say a new role, but perhaps a new avenue or a new tool that we can discover and help us. Right? We started with, I don't know, I don't think most of you here you touches a T-square and a set square before. Those are tools that we traditionally use, but now with the computer, right, and then with the mouse, and now with the script and auto script, right, and the mid journey and all that, you can just put in natural words, right, and the AI software can generate visualizations for you. So this is in fact, from what we started off with T-square and set square, now it's really a great thing, but it is still a tool. However, the thing behind it, what I'm trying to say is that the architect still possess the design knowledge, and this is the one that we cannot be replaced by a machine. Yeah.
Yeah. So I guess the answer is, right, we have to be the ones to teach the machine what to look out for. Yeah, including what to input. For example, you're inputting Zaha Hadid, you're inputting urban solutions, photovoltaic. Yeah, so these are the ones we know is going to be relevant because of our own training. So thank you, William. Thank you for all your questions. We'll be wrapping up and calling it a day. Thank you all who have joined us online and offline. And thank you very much, Gerard, for coming down. So stay tuned for our whole series of talks. This is the first of 7 now. Okay, yeah, first of 7. Yes, so stay tuned and we'll see you in the next one. Thank you. Bye.